This is Geometry Chapter 8, the final review. We're going to start off with talking about the objective that students will be able to use the Pythagorean theorem and its converse. So these first three problems says find the missing side, leave your answer in the simplest radical form. Notice that we have right angles on each of these, and you have two of the three sides. So these are just straight up, can you set up the Pythagorean theorem correctly or not? So if I'm looking at the first one, I can see that I don't know this x that's across from the right angle. That's going to be my c. So x squared is going to equal 16 squared plus 12 squared. I'm just going to set up the other three and then have you guys pause the video and figure them out. On the next one, I can see that y is attached to that right angle, which means it's going to be either a or b. I'm going to make it a. 15 is also attached, so that'll be my b, which means 39 has to be my c. I set up the next one, I look z is attached to that right angle, so is the 20, so I go z squared plus 20 squared will equal 28 squared. So what I'd like you to do now is to pause the video and just finish solving these three Pythagorean theorem problems. Alright, so you can see that I have my solutions for the first two up there. I got x is 20 for the first one, y is 36 for the second. The third one for z, you might have come to the same stage as I did, that the z squared equals 384, so the square root is, so z equals the square root of 384. But if you try to take that square root of 384, what you end up with is a decimal. And so sometimes that's fine. But if you check the directions on this one, the directions say leave your answer in simplest radical form. So my 19.59591 that I got on my calculator won't work in this case. So if you think back to remembering how we simplified square roots, we started by identifying any perfect squares that could go into 384. My personal favorites to start with are 4 and 9. So I'm going to check, is 384 divisible by 4? It is. We actually get 96. So I can rewrite that as 4 times 96. That's the same as 384. And what I can do is I can pull that 4 apart and I get the square root of 4 times the square root of 96. And I know the square root of 4 is just 2. So think about the square root of 96 though. Are there any more perfect squares that can go into that? Well, if you know your multiples of 9, you know 9 can't go into it. But maybe 4 can again because it does end in an even number. And it does. So I might take out another 4. So I get, well, 4 times 24 was the square root of 96. And I can take that 4 out again, it turns into a 2, and I multiply it by the 2 that's already there, and that gets me a 4 times the square root of 24. Think about the square root of 24 though, any more perfect squares that go into that? Well, I think a 4 goes inside again. It does. So I can pull out another 4, and that turns into the square root of 4 times 6. When I pull that 4 out in front though, it's the square root of 4, so it becomes a 2. So I get 4 times 2 out in front, which is 8, and I have the square root of 6. So that would be my answer in simplest radical form. We did spend quite a bit of time talking about that in this the second chapter, chapter 8. So this objective also talks about the converse of the Pythagorean theorem. The converse of the Pythagorean theorem essentially says that if a squared plus b squared is c squared, you have a right triangle. But there are also situations where a squared plus b squared does not equal c squared. If for some reason c squared is bigger, it means you have an obtuse triangle. If c squared is smaller, it means you have acute. If c squared is the same, that means you have a right triangle. So what you're going to figure out is, okay, what is this triangle? Acute, obtuse, or right? When you set up this a squared plus b squared as something to c squared, what I like to do is I like to go a squared plus b squared is something to c squared. And I don't know what goes in that circle yet. My recommendation, or my thing that you gotta pay attention to is they don't always give you the letters in the order A, B, C. Make sure that C is the biggest number in your list always, okay? So you pause the video and see if you can classify these three triangles using what we wrote over there on the right. All right, so we should have gotten some numbers like mine. I got 185 is something to 225 here. Well, 225 is bigger. That means c squared was bigger. That means this first one's obtuse. Go to the next one. I got 1681 and 1681. Those are the exact same thing. That means I have a right triangle. C squared's the same. And then I got 365, which is bigger than 361 right here. That means C squared is smaller, so it's acute. So we should have gotten obtuse, right, and then acute. Okay, so this one is the students will be able to use the properties of 45, 45, 90, and 30, 60, 90 triangles. These are our ratios. So 45, 45, 90 is 1, 1, square root 2, and 30, 60, 90 is 1, square root 3, 2. Now, if you remember, the way that I taught this, we said to move to the right, you multiply. To move to the left, you divide. Move to the right, you multiply. Move to the left, you divide. And so your sides go small side, medium side, large side, and they're across from those angles as well. Small, two smalls, and then your large. So if I look at this first one, that's a 45, 45, 90. That's my 1, 1, square root 2. I'm trying to find the missing side lengths, and if your answer is not an integer, to leave it in simplest form. That's why we're using this 1, 1, square root 2. And I look at what I have. I have 20, and 20 is across from 90 degrees. Well, if this little angle over here is 45, this other one also is 45. So if the side of 20 is across from the right angle, that's your largest side because it's across from the largest angle. That's going to go here. So this is a tricky one. Because to go to the left, I have to divide, and I actually divide by the square root of 2. So I'm going to take 20 divided by the square root of 2. Now we spent a lot of time doing this. If you remember, we don't like to have that square root of 2 in the denominator, so what we do is we have to rationalize the denominator. That means we multiply by the square root of 2 over the square root of 2. On the top, that gets me 20 root 2. But on the bottom, it gives me the square root of 4, because 2 times 2 is 4, and they're both underneath that square root, which is nice, because you should know what the square root of 4 is. It's 2. So I get 20 root 2 over 2. Well, we can't leave that still. What we want to do is divide the numbers outside of the root then. This 20 and 2. Well, 20 divided by 2 is 10, and we still have that square root of 2, because they're not like terms. We can't divide square root of 2 by that 2 on the bottom. That would imply then that those two blanks in my ratio are both 10 square root 2, which means x and y, which are those two blanks, are both going to be 10 root 2. So that's your 45, 45, 90 tricky ones. This next one, if you look, you have a 45 and a 90 degree angle again, which means your third angle is going to be 45. We bring our ratio back over. We have 7. 7's across from 45 degrees. That's going to be one of these ones. We'll plug it in for one of them. It doesn't really matter which. And, well, if one of them is 7, then so would the other one. And then you can go, well, to move to the right, we multiply. We're going to multiply by that square root of 2. We just go 7 square root 2. Now that we have our two answers in a ratio, but what we have to do is identify which one of them is m and which one of them is n. So you got to think about, well, what's bigger, 7 or 7 times the square root of 2? And if you think about 2, it went small, small, large. This is going to be our larger number. So we look at the two sides, which one's across from the bigger angle? Well, n is across from 45 degrees, and m is across from 90 degrees. Well, m's across from the bigger angle then, so m's going to be the bigger number, which means n is the smaller number. Hopefully those ratios are coming back to you now. We move on to the next two. These ones are a little bit different because they have a 30 degree and a 90 degree. That means that third angle is 60 degrees. And that means we're dealing with our 1 square root 3, 2 ratio. Now this one, if you haven't realized, is a bad picture. Because if you look at these two angles, the 30 and the 60 degrees, well, 30 degrees is a smaller angle, which means B should be the smaller side, and 9 is got to be the medium side then. So when I plug that 9 into my ratio, it's across from that medium angle. It means it goes in the middle. So that means this is not our favorite problem ever. Because to move around in that, we have to divide. And so what we do is we divide by that square root of 3 in the ratio, and then we have to kind of treat it like we did that last one where we had to rationalize the denominator. So to rationalize, you multiply by the square root of 3 over the square root of 3. We get 9 root 3 over the square root of 9. And then we get 9 root 3 over 3. And we can simplify 9 over 3, and we get 3 root 3. That's going to be our first number in our ratio. Now I always said go left and then go right. So now that you have that 3 root 3, it's easier to go get that larger side because you just take it and you double it. Well, you double the number out in front, that 3 out in front. So that becomes a 6, and the number underneath the root should stay the same. And now we just have to figure out, well, which one is A and which one is B. A is across from the 90 degrees, and B is across from the 30. Well, 30 is smaller. That's going to be that first number then. So your B is going to be 3 root 3. And 90 is the larger, so it's going to be the last one on your list, 6 root 3. And you found your two sides. This next one should be a little bit better for us. We're going to use that 30, 60, 90 again, because we have a 60 degree, 90 degree, and then a 30 degree. Which means we're going to use 1 square root 3, 2. We look at the one side we know, 42, and it's across from the right angle. Which means I'm going to put it last in my list, because the right angle is the largest. Now, when you go on this one, you want to go all the way back to the beginning, because it's easy to go from 2 to 1. To get from 2 to 1, I divide by 2. So to get from 42 to that first number, I'm going to divide 42 by 2, and I get 21. Then I move to get that middle one. Well, to move to the right, we multiply, and you multiply by the number in its spot, square root 3. So it's just going to end up as 21 square root 3. Now we have to figure out which one is which. I look, Q is across from the 30, and R is across from the 60. That means Q is the small, R is the medium. So the small one is 21, that's our Q, and the medium one is 21 root 3. That's R. All right, I hope some of this stuff is coming back to you now. All right, here's the next objective. After we talked about special right triangles, we then moved into talking about trig and using trig to help us solve. So our trig stuff that we used was the phrase so, katoa. We were able to use those to identify which trig function to use when. And what we use trig for is that to determine side lengths and angle measures in these right triangles. That's what the objective is talking about. So it says find the missing value to the nearest hundredth. If you remember when you set up sine, regular sine, this number on the inside is your angle, and this out here is your ratio. Now since this is sine, it would be opposite to the hypotenuse. So if you had a picture, 5 would be the opposite side to the angle, and 15 would be the hypotenuse. Now when we were trying to solve for that angle measure that we didn't know, we didn't use regular sine, we actually had to change it and use sine inverse. And then with the number that goes inside the parentheses is actually the ratio. The ratio and the x, they switch places, and we go 5 over 15. Now I'm going to pull up a graphing calculator and show you how to type that in. So here's my graphing calculator. Sine is this button right here that I just clicked. It's showing up in red, but we don't want sine, we want sine inverse. So instead we hit second sine again, and see how that -1 has popped up? That's our inverse sine. And now we just type in that ratio. The ratio was 5 to 15, and we hit enter. If you get something like this that doesn't make sense, that means your calculator is in the wrong mode. So watch the red buttons where you get the mode clicked. So up at the top it says second mode, so I hit the mode. I go down 3 to where it says radians, where my flashing black cursor is. I go over to degree, and I hit enter. Now if I try that again, I second quit out of there. I go sine inverse of 5 divided by 15. I should get a number that makes a little bit more sense, 19.47. That would be your angle measure then. So we write that in degrees. It says round to the nearest hundredth. So we're going to say that x equals 19.47. You pause the video and try the next one on your own. You can check your answer with mine. I got the angle to be 66.42 degrees. So on this next one, we're just checking is, can you set up the ratios for these different angles? We're not asking you to find how much the angles measures are, just set up the ratios. So that's just setting up sine of angle A is going to equal the opposite to the hypotenuse. I got that from SOHCAHTOA. Now what you're looking for is what is the opposite side and what is the hypotenuse side. So I always like to mark my angle and I go, okay, well opposite, that one across, that's going to be here. Hypotenuse is that one across from the right angle, that doesn't change, that's going to be 25. So it's just going to be 24 over 25. And you're going to do the same thing for cosine and tangent. Now there's a trick when you get the tangent. Let's see if you can catch it. Pause the video here and try the next two on your own. Your cosine of the angle should be 7 to 25, and your tangent of angle B, they switched angles on you, should be 7 over 24. So if you put 24 over 7, you didn't pay attention to the fact that the angle changed for tangent. All right, so what you're going to do next is you're going to move down to these next ones, and you're going to find the values of y. You're going to round your answer to the nearest tenth. So this is where all those trig skills come into play. You look at the triangle, you mark your angle, and you look at your sides. Well, y is opposite, and 18 is the hypotenuse. So if I think of SOHCAHTOA, I have to determine which one uses the opposite and the hypotenuse. That's so. So I go sine. Now, regular sine uses the angle measure. We have the angle measure of 41 degrees, so we just plug that in. And that equals the opposite side y to the hypotenuse 18. And we essentially just want to solve that equation for y. So if I'm dividing by 18, I would just multiply both sides by it. And y is just going to equal 18 sine of 41. Now you've got a calculator. You go type that in. So watch me type that in. You can type it in with me. I'm just going to type in 18. And then I go just regular sine. And then in there I put the angle measure 41. Hit enter. I get 11.809. It wants me to round to the nearest tenth. I'm going to round that to 11.8. So y equals 11.8. You try to set up and solve the next one. You might have gotten to this point and been like, well, what do I do next? I can't just multiply both sides by 9 because y is in the bottom this time. So essentially what happens is that the cosine of 53, the whole thing, and the y switch places. Because you're going to multiply both sides by y and then divide by cosine. So essentially we're just going to say y equals 9 divided by cosine of 53. And you just got to type that in. So we go back to our calculator. We go 9 divided by cosine, that's right next to the sine button, 53. We hit enter. We get our side. It's 14.95. When we round that, we would say y is about 15.0. Okay. So after we started to introduce sine, cosine, and tangent, we started to do application problems with them, like this one. So students will be able to use sine, cosine, tangent ratios to determine side lengths and angle measures in right triangles. So we had like a whole worksheet actually of word problems, and this one talks about a tree. So the tree's shadow is 72 feet long. The angle of elevation from the ground to the tree is 38 degrees. That's this angle down here. Angle of elevation is how much you're looking up. It says how tall is the tree? Well, this is the height of the tree. We're going to call that x. Once again, just like the two pictures beforehand, we just have to figure out which trig function it's set up. So we look at the sides in regards to the angles. Well, 72 is adjacent, 30, and x is opposite. Opposite and adjacent is my tangent. And I go, oh, do I know the angle? Because if I do, I use regular. If I don't, I use inverse. The angle is 38, so I know it. And then I just go opposite x, adjacent 72, and I just continue to solve from there. I'd multiply both sides by that 72, and I would get x equals, I can go type it in, 72 tangent of 38, enter, and I get it to be that the tree is 56.25 feet. And it tells me to, doesn't tell me what to round to, so I'm just going to put 56.3. 56.3, now this was a word problem. You're talking about the height of the tree, so you should talk about, well, how tall it is. In regards to a unit, it's feet. So you would say 56.3 feet. Here are two problems where it says find the value of x round to the nearest degree. So these are trig problems again, but the trick on these ones is that you actually don't know the angle measure. So instead of setting up your tangent or your sine or your cosine, you're going to set up those inverses again. So why don't you pause the video and try these two on your own. So these are what I set up. I set up sine for the first one, sine inverse, and tangent inverse for the second. When I type it in, it does say around to the nearest degree, so I'm going to get that x equals, and I got 35.68, so it's going to become 36 degrees. And for the second one, I type it in, I get 29.74, so that's going to round to 30 degrees. All right. So after that, we started to talk even more about word problems using angles of elevation and angle of depression. And so on these ones, we don't have a picture. And so what you really want to make sure you take the time to do is to make a picture to go along with it. So it says you would lean a ladder 6.7 meters long against the wall. So here's my wall. Here's the ground. Here's my ladder. My ladder's 6.7 meters. And if you think about it, the wall and the ground usually make a right angle. So I can put that there. The ladder, makes a 63-degree angle with the ground. So I look, ladder's here, ground's here. That's going to be 63 degrees. How high up is the top of the ladder? Well, they want to know how high up it is. That's the height, x. So we're once again just getting to the picture so we can set up a trig function. I look, I have my opposite, I have my hypotenuse, that's my sine. I know the angle, so I can plug it in. It equals the opposite over the hypotenuse. I multiply both sides by that bottom. I don't have to do any switching this time. And I can get my x. I just go 6.7 sine of 63. And we should get it to be about 5.969. It doesn't tell us what's round to. I'm going to give it just 2 decimal places to be safe. 5.97. Now, it didn't ask us what x is. It asks us how high the ladder is. So when we write our answer, we should definitely give it a label because this is talking about how tall and how long things are. So meters is the label they used originally. That's what I'm going to use again. This next picture is a little bit tricky. It's talking about a submarine. So you have a sub and it starts at the surface of the ocean. So here's the surface of my ocean. And then it's going to make an emergency dive. It's going to go down and its path makes a 21-degree angle with the surface. So it's not just going straight down, it's coming down at an angle of 21 degrees. It's called an angle of depression. If it goes for 300 meters, this is the path it's on. It goes 300 meters. How deep will it be? Well, that's this value right here. Let's call that y. And then, what horizontal distance is it from its starting point? Let's call that x. If you think about the depth and the surface should make a right angle. And we just have to set up 2 different trig functions and solve for both variables. So why don't you pause the video now and try to solve for both variables. If you check your solutions with mine, you can see I got x to be 280.07 meters and y to be 129.01 meters. That's a mistake. Let me pause and fix that one. I made a typo. I couldn't read my own handwriting. I thought I had written a 360 there, but if I use a 300, my y should be 107.51 meters. That makes more sense. And then we have to label our horizontal distance. That was the x, 280, and our vertical distance, that was the y, 107. All right, this last objective is that students will be able to describe vectors in a vector direction. So it says describe each vector as an ordered pair, round the answer to the nearest tenth. So when you describe it as an ordered pair, that means you need an x value and a y value. So here's going to be your x, here's going to be your y value. And so what you're really looking for is the xy value of that end point of the vector. So what you want to typically do is you want to make a right triangle. So I would bring this maybe up to the x-axis. That's what I usually do. And then you can look that you have an angle of your right triangle, and I can put a right angle there, and I have a side of 42, that's this entire side length, and I have 2 sides I'm looking for. So I think, well, x is the horizontal distance, that'll be here, and y is the vertical distance there. And then essentially at this point, what you do is you just set up the trig functions and you solve for x and y. So I look at maybe x is adjacent, 42 is hypotenuse, that tells me cosine. I go cosine of 28 equals the adjacent over the hypotenuse. I'll solve that one in a second. I can do a similar thing with y. Y is the opposite. I have the hypotenuse. So I can go sine of 28 equals the opposite over 42. In both of these two, I'm going to just multiply by 42. multiply by 42, and then just grab a calculator, type them in, and we should get some values out. X, we should be getting 19.7, and Y, we should be getting 37.1. So you can put those into our ordered pair, but we still have one more step left in our ordered pair. Because we are talking in the coordinate plane, you have to think about the positives and negatives of that value. If I'm looking here, well, X when it moves to the left is negative, so I put a negative, and Y is negative when it moves down, so I have to put a negative as well. And then that is going to be my final answer. You can pause the video here and try the one to the right on your own. All right, I drew in my triangle, I marked my angle. My right angle is right there in blue. It'll draw, there we go. I set up cosine for X, sine for Y, solved them, and I got the same answer for both of them, 46.0. It's really 45.96, but that rounds to 46.0. And then if you think about it, X is positive when it moves to the right, and Y is positive when it moves up, so we don't have to add any negatives to our picture. So the last thing we have for you is here, it says use compass directions to describe the direction of the vector. So this is where we talk about something being north, south, east, or west. And so when we write this, we write some angle, some degrees, something of something. So we start with our angle. Well, it's 55 degrees. We can put that in. And then the second one is the compass direction you put in that the angle is attached to. So the angle goes off like this, but it's attached to the east. So we put our east here, and then we put the second direction that it goes. Well, it's going north of east. We put that first. All right, you pause the video and you try the next one. You can check your answer. I got 20 degrees west of south. All right, well, that was chapter 8, all about triangles, right triangles, special right triangles, and vectors.